Here we have an example that is just slightly different. It says that we have a vertex at 0, 0, and a directrix is the line y equals 1/4. Okay, and our directions, if you saw the last video, are going to be the very same. We need to come up with the equation. We need to come up with the endpoints of the lattice rectum. So I went ahead and wrote those out, and we need to draw our picture. Now, I went ahead and wrote out the focus, the vertex, and the directrix because those are the other important parts. And I went ahead and put in what we know, what they gave us. They gave us that the vertex was at 0, 0, so I plotted that. And they told us that we have a directrix at y equals 1/4. Well, y equals 1/4 is very tiny up here. I know that the way I've drawn it, it probably looks more like half, but we're going to pretend like that's really 1/4. I need a better graph that's a little larger in order to be able to really see that much better. Okay, so this is what we're starting with. This is what we know. We have to figure out where can we go from here. If our vertex is here and the directrix line is here, what do we know about this right now? I mean, can this thing open up? Well, no. It opens around the focus, but the directrix is always behind it. So that tells us that our focus has to be down here, which means that this parabola is going to be opening in the downward position. So we know that right now. This thing opens down. Now, we also know that the distance from the vertex to the directrix is some a units. So we know right now that a is 1/4 because that is 1/4 units. Which means 4 times a, well, 4 times 1/4 would be 1. So we know that already. Now from that, if it is a units to the directrix, it is a units the opposite way to the focus, which tells us that our focus has to be right here, 1/4 units away from the vertex. We could go ahead and label that point. That point is nothing in the x direction, but down 1/4. So our focus is at 0, negative 1/4. We also know that the lattice rectum is 4a units long. So if this is 4a units long going through the focus, that means it's 1 unit long. We'll have half on one side and half on the other. Oh, this is going to get really tiny. So I'm going to go over here 1/2 unit, and over here 1/2 unit. And that's as big as our parabola is going to be. This thing is going to be very tiny. But we do need to name those endpoints of the lattice rectum. Let's do the left one first. To get to that point, you have to go, remember it was 1/2 to the left and 1/2 to the right, 1/2 unit actually, because it was half of 1. So we would go negative 1/2 in the x direction and down 1/4 in the y direction. So negative 1/2, negative 1/4 is that leftmost lattice rectum endpoint. Now let's go to the one on the right. So to get to that one, we'd have to go 1/2 unit in the x direction and down 1/4 unit in the y direction. So that would be 1/2, negative 1/4. We have our picture drawn in. We have everything we need except the equation. Now, if it opens down, that means it has to follow the form of x minus h squared equals plus or minus 4a times y minus k. We know our h and our k because of the vertex. That would be 0, 0. We know 4a is 1. And because this thing opens down, it has to be negative. So let's clean this equation up. X minus 0 is x squared equals a negative 1, so we'll just do negative. Y minus 0 is y. So there's everything we need to know about that parabola.